fourth bi-weekly meeting, right? So today we have three things to talk, and starting from now to half past 8, we got to discuss about our new router written by Byron, and later we will dive into our speculative decoding and X grammar. So I guess everyone come here for your own interest, but feel free to discuss about other things you'd like to say. And lastly, we got to discuss about our KV cache. So we have three speakers today, so we'll get started right now. And Byron, are you ready?
Yes. Okay.
Okay.
Let me share my screen.
Okay, cool. Let's go.
Okay, so I'll provide a quick update for the new SGLang router feature. So a recap from last time. So we talked about the design doc. And in the design doc, we have 4 requirements. So the first one is prefix cache aware. So we want to make sure the request which has a high prefix match can be routed to the same node, same worker. And also we want to make sure load balancing. We don't want any worker to be overloaded or underloaded. And also we talk about like we want to maintain fault tolerance and we want to provide a WaveSync API to enable Wave can be synced by the internet. And this is the link of the design. So I will share the link of the slide afterward. You can go through it. Okay. And the next part is that so the first phase of the of this feature is that we want to implement the first two parts. So prefix cache aware and load balancing. And the current architecture is like this. So each worker will have a SGLang instance, and on the instance it will have a server, either like HTTP or gRPC. But now we use HTTP. And on the router side, we also host another HTTP server. So essentially, the job of the router is to forward the request to the best fit worker. And the tricky thing is how do we decide the routing policy? Yeah. And the progress we have done, the first one is that we have done a POC for, wait a second. We have, wait. Okay, we have done a POC for Python router versus Rust-based router. Python router is pretty easy to implement, but it was very, very slow. And we concluded that Rust HTTP router nearly introduced no overhead. For example, if you have a worker instance and you put the router in front of it, and DP is equals to 1 now. And we observed that there's nearly no overhead. So you can check this PR for more info. You'll see that we experiment with the original dash DP is the original data parallel method. But the drawback is that it can only be served on one node. And the Rust-based router can be served to multiple nodes by the two-level HTTP server architecture. And you can see here. So the yellow one is the Rust router and the red one is Python router. And you can see clearly that a Rust router is definitely much better. So that we decided to use Rust. And then we started to implement we design a cache-aware algorithm. So essentially, the algorithm is that we simulate the tree on the router side. So, and also we try to minimize the communication between the router and the local. So we just use the available information on the router to construct the tree and to approximate the local tree. And we implemented the first version, and we can see that the performance is so the blue one is round robin, and the red one is the Rust approximate tree. And you can see that so the data set is the one with high with long prefix. So you can see that the latency is much shorter and the cache hit rate is much higher. And the cache hit rate, the effect can be more significant if you scale up to multiple nodes, because by using round robin, you tend to just scatter the request to everywhere. And by using the approximatory, you can gather the request with with long prefix together. Yeah.
Hey,
And
Byron,
hi.
I have a few questions here.
Okay.
So, do you run tokenizer in the load balancer?
Yeah. Right now, yes. But we in the next version, I'll get rid of that.
I see. So, like in your current code, do you use the Rust interface for the Hugging
Yes.
Face tokenizer? I see.
Yes.
And the whole router, does it support the streaming now?
Yes, it supports streaming.
I see. Yeah.
Yes.
Yeah, I just want to learn more. And you mentioned you want to get rid of that. How can you achieve that?
So instead of constructing the Redux tree using token, we construct the Redux tree using character. So because we just want to approximate, so either ID or character doesn't matter much. Yeah.
Okay, this is interesting.
May I ask a question as well?
Yeah, cool.
Sure.
So with router in place, what is your strategy? Do you plan to also support the batching endpoint as well?
Yeah. So it will have the same interface as Julian instance. Basically, it just forwards a request and
Okay.
load balance. Yeah.
Hi,
Thank
Ben. What kind of batching interface are you talking about?
I was specifically talking about the OpenAI batch interface. I found that y'all support for that really, really nice, actually. To be able to just upload a batch of requests and have them processed. But I was actually contemplating with a friend of mine on building a router that would go in front of like VLLM or something. And we were trying to figure out the best way to support batching, because if you have a number of VLLM workers and you want to support batching and the router handles the batching and distributes the load to the least loaded node, then your cache hit could be quite low, because that node might not have the previous experience with those hits. So I was thinking through this myself. I find it interesting.
I
Okay.
see.
Oh.
Yeah, so
Oh.
this I think this can be applied to that. So, but right now, right now I don't think this has like good support for like OpenAI compatible API, but underlying all the techniques can be shared. Yeah, like
Yeah.
if you need an OpenAI compatible API, you can either wrap it a layer by yourself, or you can like switch to like our native API, so you can send a batch of requests.
Understood. Thank you very much.
Lisa, hi.
Yeah.
I have a question. Sorry, quick one.
Yeah.
Yeah. So, how do we consider the model behavior? For example, right now, I was assuming the router probably not good to break into at the token level to load balance, right? Because let's say you have MOE, right? Let's say you have MOE on one node, which runs over select 2 over 8 expert. Now, if you do load balancing to 2 node, you have 16 GPU, but model never trained works for 16 expert. So still 8 expert. You want to duplicate. You want a 2 copy of choosing 2 over 8 expert. You don't want to change the behavior to say, okay, I interleaving with 16 GPUs, 2 nodes, for example. So I would consider, is there a problem like that? If we load balance at token level or character level, for example.
I think right now one request will just stay in one worker.
Right, one request means the whole session, right? Whole request.
One request, like generate request, will stay in one worker
Okay.
until the decoding is finished.
Okay, that's cool. Because like I probably misunderstood. Because you when you say you tokenize around node balancer or you don't do tokenize around node balancer, you do registry on the chars on strings. So okay, I think that's cool. Yeah, I just don't understand if we're breaking into the release the request to load balance. Okay, yeah, I think that's good. Thanks.
This load balancer happens at the orchestration layer. It's
Yes.
supposing that you have multiple replicas. Say if you have like thousands of the workers, but each worker can have multiple GPUs to run whatever the DP at what different TP sites. And then the router is responsible for dispatching the request to these different replicas.
Yeah, but it maintains the
Maintains the registry is just for the heuristic of dispatching algorithm. But when the request arrive at the replica, the engine itself will run a local registry at the engine in the engine itself.
That's cool. So basically, the
Oh.
router doesn't look at the lower level of information. Once request determined to go which replica, it just keep going there, right?
Yes, and then the engine handles everything as usual.
Yeah, that's cool.
This is
Thank you
very
for-
cool.
Oh, unclear algorithm. So you are somehow you are implementing somehow a naive version of registry on the router level, and you just
Yes,
dispatch
yes.
your requests. Okay.
Yes.
So I guess this is already a simple somehow greedy search methods on that naive tree, right? Just
Yeah, this is like a simulation of the actual local tree.
okay, clear methods. Okay, go across. Thanks.
So can you introduce your approximation?
Oh yeah, I'll talk about that
Yeah,
later.
okay, cool.
Let me. What was your question?
Another question is, how do you know the load? Will the router, like what kind of information will the router try to get from the workers? For example, will the router get number of running requests, number of prompt tokens, decoding tokens?
Yeah.
This from
So it will have a number of running requests, and it will. So on the router side, it will maintain queues. So it will note down the current running request, and that will be determined as a load. For example, so it's a map. If a request is sent into one worker, then it will increment. If it responds, then it will decrement.
I see.
So it can, yeah.
So will that be useful if we also take into account like if we do balance at token level? So for example, also take into account prompt tokens, completion tokens,
Yeah, I think that's useful. So to be a more granular info of the load. Yeah, that's possible.
Okay.
Just to
Yeah.
reiterate to make sure I'm understanding, so what you're doing right now is the router has queues for each one of the workers and you're deciding where to distribute a request based on the number of requests currently in queued for that worker versus the amount of requests
so
that it can process.
It's a bit more complex than that. So on the router side, you will have let me show a diagram. So, okay, So this is a router and this is a worker. So on the router side, we'll have the approximate tree of the actual tree. So for example, if worker have 4 tree, and on the router side, we also have 4 tree to approximate the tree. And apart from that, we also maintain the running queue. So to keep track of the actual running request. So it has 2 states. One is the approximate trees, and the other is the running queue. Yeah. This is the current approach.
Understood.
Yeah. Okay. I'll go ahead. And the third thing we have done is to set up the ROS infrastructure of SGLang project, including the testing CI and Python binding and publishing. So eventually the router will have a Python interface. So you can just use it like a Python library. It's just like Hugging Face tokenizer. So we also provide a SGLang router that you can interact with the Python library. Yeah. Okay. And some technical challenges we have met is that the first one is that we noticed that Python HTTP server is very, really slow. And the main reason is the serialization and deserialization of the request. It takes a lot of time, and Python cannot parallelize it very well. And another few problem is that, so we have this architecture, right? But we want to minimize the communication between worker and router. The best case is that it doesn't need to communicate. And the other thing we want to minimize is the difference of the actual tree and the approximate tree. We want to make them as close as possible. And we also want to have a benchmark that can showcase. So for this router, it can showcase its power. So the benchmark we design is that so we simulate a real world use case, which provided a very long system prompt and then several QA. And they have multiple group, and each group has a shared long prefix. And we use that for benchmark. There's also a PR for this one. Yeah. And benchmark of the current progress is that, so I implement a prototype version of current ROS approximate tree, and you can notice that compared with the round robin, the latency is much lower, and the cache hit rate is quite high. And the ideal case here is that, so I just mentioned there are multiple groups of shared long prefix, right? And the ideal case here is that we assume the same group going to one worker, and we measure the time running on one worker. We mark that as the ideal. And we can notice that there are still some gap between our current implementation and the ideal case. And we believe that this can be optimized by reducing the concurrency overhead, because we think that we're not using the lock unlock efficiently now.
So if you hit rate are almost there with ideal, so why the execution time has big difference?
Yeah, so because on the router side, we need to maintain multiple approximate tree, right? And we use mutex and rewrite lock for that. And yeah, I think now the overhead is still a bit high.
Okay, thanks. Yeah.
Yeah. Okay, and the last slide is, so the ongoing work is that we want to merge all the approximate tree together into one tree, so we can save the memory and also make the query time much faster. We just need to query once to find the longest match worker. Yeah. And the second thing is that we want to implement eviction policy, because we cannot keep the tree growing forever. Otherwise, the RAM will blow up. So I also design so essentially the policy here is to mimic the local policy that always evict the LRU leaf. But the difference is that we do it periodically. Say we do it every 15 seconds, because if we do it too frequently, the overhead is very high, and it is actually okay for the stall leaf to stay for a while, and then we evict them. Yeah. And the third thing is that we will keep optimizing the performance of the concurrent overlap tree to minimize the concurrency overhead. Yeah, that's my progress.
Oh, well, pretty cool. So we still have possibly 10 minutes left. Are there any questions regarding the project? And
Yeah. I have a question here. So so how you do the approximation?
Oh, I list down the algorithm here. You can take a look. I think it'll take a bit long to explain. I will
Okay.
share it offline. But we do have some change to the policy, so I will also update this.
Yeah. The other
Yeah,
question,
it-
like, do you do HA? Do you design router A and B, like A plus one, or you know?
I think it's possible to offload the tree to some shared data storage, so that if one router die, the other can quickly pick up that router. That approximate tree.
Yeah. Okay.
Yeah, we just need to offload the state to some shared data storage.
Yeah. For the range of workers, we had a kind of capability to scale out, right? Let's say you have 8 worker, now you want to add one more or two more. The kind of
You mean dynamically?
like you can design API saying I through the API I have two nodes rolled in, and now since once committed command you need to deal with 10 workers from 8. Things like
I
that.
see. Yeah, that's possible. You mean originally it had 8 workers, but in the middle you want to add 2 more.
Yeah. Or you
Yeah,
bring down one and go maintenance and upgrade the one to bring back in or something.
that is possible, but I haven't implemented it.
Will that disturb all the distribution of your selection algorithm for workers?
No.
Like you don't want to it's not hash, I know it's not hash, but you don't want to generate disturbance to what already you choose to be on
Yeah,
certain work.
because for the already dispatch one, it won't be interfere. And the new one, it will use all the new worker plus the old worker. So I think it's okay.
Okay, thanks. That is cool.
Yep. Any more questions?
So how do we try? Because like this is on Kubernetes, right?
Yeah. It's actually, I think, orchestrator agnostic. You can use any orchestrator to host it, to host the router. You just need to connect the router to different worker.
Okay.
Yeah.
Have we considered a lightweight router, not our HTTP proxy? Just look at the TCP level. It's impossible, right? Because you don't have power to see what's inside, right?
I think it will be a little bit tricky because on the worker side, it now exposed the HTTP interface. But we do consider to implement gRPC.
Okay.
Yeah. Okay.
Yeah, thank you. This is good, very good. Yeah, thanks.
Okay.
Oh, okay.
So I'll call it here.
Okay, that's pretty cool. So if anyone of you interested, you can ask question in the general. And if you would like to contribute, we have a private channel called Zhejiang Router, and hope you can enjoy that. Yeah, we're going to move to the second part. Yeah, and Yemi will discuss about X grammar and speculative decoding on the roadmap. So welcome, Yemi. Yeah.
Hi, I will just go over some important PRs over the last 2 weeks.
Yeah.
Let me share my screen.
Okay.
So yeah, I think we have 3 important PRs I would like to highlight. The first one is speculative decoding with Eagle 2. So he contributed the speculative decoding, and we chatted with him multiple times offline. I think although he didn't paste the speed up here, but I think he showed me some data. It's very promising. I think we can get like 2x speed up for small batch size, and up to batch size even 1632, it still show like 1.2x speed up. And I think also Eagle 2, I think it's the current best speculative decoding. So like right now, we will mark this as a very high priority item, and we would like to merge this very soon, like in 1 or 2 weeks. So yeah, this is a very important PR. Like if you are interested, you can review. I think late next week we will start to review this PR and try to integrate this. Okay, this is about the first PR, speculative decoding. And then the second one is support data parallelism for attention layers. So if you want to run DeepSeek model, you will notice their model only has one KV head. So for example, if you want to run TensorParallel 8, then like one head, you cannot partition that. So you have to duplicate the KV cache. So in this case, it will cause some redundant memory usage. And also this will limit the batch size. So this is very bad for throughput. And in this PR, could introduce the data parallelism optimization. So what we will do is for attention layers, we run data parallelism. And for MLP layers, we run tensor parallelism. And then in the middle, we'll use OrGather and slice to switch between them. And then, so this one, it has not been integrated into router yet. So this is still using our old data parallelism infrastructure. So it will launch many like totally independent schedulers. But when they run the forward pass and when they go to the attention layer, they do its local computation. Like everyone runs totally different things. Someone can run prefill, someone can run decode. And then when they go to the MLP layers, they will join and run tensor parallelism. Yeah, so this is very cool. And you can see for like DeepSeek model, if you run on 8 GPUs, you can get 20% throughput improvement for prefill and around 70% for decoding. But there's still a lot of optimization can be done. For example, how can we achieve better load balancer? How can we achieve better load balancing across DP ranks? And also like how do we make it compatible with CUDA graph? I think Ke will work on that in the following weeks. But I think this is a very cool feature, and I guess probably SGLang provides the first open source implementation.
分手上周吧。
Sorry, do you have any question?
Hello, are there any question? I think now we can go ahead. Right.
Yeah. So yeah, I think this is very cool, and so SGLang will still be like the fastest inference engine for running DeepSeek models. Okay, this is the second PR. And then the third PR is about XGrammar. So previously, XGrammar is a grammar parsing library for grammar guided constraint decoding or structured output. So previously we use outlines, and outlines is implemented in Python and it's very slow. And so recently, like MLC or a lab from CMU, they open sourced the XGrammar library. So it's just open sourced last week. They are still working on some like finalizing the code base and documentation. I guess they will release, like they will do an official release in the following 1 or 2 weeks. But its integration is already in SGLang. And I tried that. Like the pre-processing is much faster than outlines, but they are still rapidly iterating on their APIs. So we will work closely with them to make it fully ready. Okay, yeah, I think that's probably all the important PRs over the last 2 weeks.
Okay, I think that then you are specifically coming for the XGrammar, right? Do you have any question regarding this?
I don't. I'm very, very excited to see the XGrammar edition. A lot of my workflows revolve around doing a lot of batch generations all under schema to fill Pydantic models. So that's very exciting. Do you have any information you can share about the performance of XGrammar versus outlines?
Yeah, sure.
Initially?
We have a lot of benchmark data here. It's in the first PR. So is in this PR. So here we run benchmark, like for because XGrammar previously it's mostly accelerating the pre-processing time. So in this case, we run maybe like 100 like fresh JSON schema. All of them are different, and then we benchmark like on batch setting and also on single request setting, and you can see the average latency. Let's just look at the first row. If we use outlines plus echelons jump forward and run at a large batch size, the average latency for each request is 3 seconds because most time it needs to process to pre-parsing the grammar. But if you use XGrammar, the latency is only 0.7 seconds. So it's a very significant speed up.
Yeah, that's huge. So could you elaborate on jump forward? Forgive my ignorance. Is that essentially like if there's only one option of a certain token or a certain string going forward, we'll go ahead and move to the next spot where we have a generation opportunity? Or what do you mean by jump forward?
Yeah, it's exactly what you described.
Okay.
Yeah.
This is awesome. I'm very, very excited for this. Thank you for sharing.
Yeah. So for the jump forward, it has been like supported like 10 months ago. January we released this blog post and we compare sklearn versus like other libraries, and we can see it's much faster. This is already there with outlines, and also with XGrammar we can do something similar.
Amy, I have a question. Why the number of outputs are different for XGrammar and outlines?
Let's see. Let me go back here. Average output tokens, I guess, because it's I think there are still some randomness in the generation. So the output tokens are slightly different. But if you look at they are produced JSON, it's very close. I think this is randomness from the model or from the dynamic matching.
So is it fair to say that under XGrammar when generating our latency between tokens may be a little bit longer than outlines, but our prefill rate is much higher?
This is not very precise. So XGrammar in every step is faster than outlines. So like dominantly better.
Okay, I'm very excited about this. Thank you for sharing.
So it does pre-processing faster, also does per token generation faster, and also like everything is faster.
But average output token wasn't faster, looks like, right?
Yeah, like everything is faster because it does caching and generate mask faster, and also has optimized kernel for applying mask. Yeah, it's a very cool library. Yeah, let's wait for them to release it, and like we'll maybe contribute some data for their release blog post.
Hey, I have a question, naive one. Do you see is any case like this structure-based decoding or jump forward can works for VRM type of thing?
Yeah, like they already works. All this supports vision language model. You can, I think it's supported from the very beginning. If you go to the blog post, if you go to blog post, attend, right? It supports describing the image into JSON format.
But the image generation itself cannot jump forward, right?
This is image input, text output.
Okay. If you have image generation as well, will that work? Like,
I think that is out of the scope of current sklearn, right? We don't support any image generation model. But if you use like autoregressive image generation model, maybe you can do this.
okay. Yeah, thanks for this. Yeah.
Okay, that's probably all of sklearn update. Yeah.
You're on
muted.
mute.
Okay. Sorry. Are there any more questions about these parts? Yeah, if not, we got to move to the final part, and we have so much time left. So, if you still have questions, you can somehow interrupt at any time. And the final thing we got to describe about our teaming slides channels of KV Cache, and let's welcome Lin Ke. Yeah, you hearing?
Can you hear?
Hello. Yeah, we can hear. Yeah.
Oh, thank you.
Okay. Do you have the access to share your screen?
Can you see this one?
Yeah, we cannot hear it so clear. Maybe you can check your microphone. Yeah.
Okay.
Oh, clear. Yeah, right now. Yeah, cool.
You see the
Let's go.
screenshot?
Yeah, cool. Let's go.
Okay. Thank greetings. I'm Link Song. In fact, I'm a system guy and I don't have some basic knowledge of AI. So it's a great pleasure for me to have a golden opportunity to have a discussion with SGLang team. About 2 months ago, we opened an issue in the GitHub repo of the SGLang project, hoping we can have some discussion about the possible timing side channel, the KV cache. And now it comes true. We'd like to express our thanks again to the SGLang team and Lianming Zheng to give us a chance. So first of all, let me just introduce our motivation. In fact, we've used the SGLang project for a while, and we are impressed by its decent design, especially by the shared prefix KV cache. But as we studied further, more concerns about security of SGLang have arisen. That is, when a new prompt comes, if the token KV pool has its prefix tokens info, the prefill process will be accelerated, which can be reflected in TTFT. Taking the following graph as an example, if a new prompt with a prefix like you are helpful assistant comes, it will be accelerated, which can be reflected in TTFT. So after that, we come up with a threat model shown here. This threat model is divided into 2 parts. So first, in the offline phase, an attacker can send is itself a user. It can send different requests to the LLM system and gains different latency here. By studying the latency difference, it can infer some state changes of the LLM system. After obtaining the timing differences in the offline phases, during the online phase, the attacker can gain the ability to understand the latency during the response process. That is, after the victim, the client sent its prompt to the LLM server, the attacker can now send another prompt and records the latency and try to infer the client prompt. So the potential to leak something of the client is excessive. But if the leakage is not distinguishable, the threat model here will be a nonsense. So we first want to indicate the existence of the leakage. We've tested in Llama 2 13 billion and Llama 2 17 billion GPTQ on a single NVIDIA A100 GPT device and plotted the ROC curve to fingerprint the timing differences when the prompts shares a prefix of different lengths. We have tested several lengths. We keep the length of the sentence the same and compare with the prompt sharing no prefix at all. By select one prompt and change the first, second, third, fifth, ninth token. And here is the result. Although the difference is very subtle, larger model is seemed to be more vulnerable to leak something. You can see on the right graph that even with one token shared, the AUC here is not is a little bigger than 0.5. So here is another graph to better to demonstrate this phenomenon, which shows the distribution of TTFT differences with sharing no token or sharing one token or sharing 2 tokens. You can see also these three groups kind of interleave together. An idea might come to be reasonable. So that is whether it is practical to try to train a classifier for us to distinguish these kind of groups. So here comes our design. Some key features are mentioned on the right. In fact, the PPT is organized simply for a 10-minute slot, so I don't have, so I haven't planned to explain the whole design here. So let's simply skip for some key features here. So we first use a fine-tuned language model to guess the next token, and use a classifier based on the timing differences in the offline field, in the offline phase to judge the guess is right or not. On this, secondly, we've tried to design some methods to amplify the phenomenon, and we found that the AUC of one more shared token can be increased from 0.529 to 0.58. That is simply this one, 0.529. More importantly, we use a function provided by echelon, that is flash catch. This is very important for attacking, since when the guess is the same, the latter prompt will be accelerated. Therefore, the attacker itself might interfere itself. So we can test immortals using flash catch without interfering. Therefore, we can improve the success rate. We've designed a theoretical token by token algorithm on the left part of this slide to recover victim prompts. Detailed information is provided in our GitHub issue. However, we still face some difficulties shown below. First, as we can see in the ROC curve, one token timing differences are still too subtle to be fingerprinted easily. Some tasks like computing intensive tasks of CPU may have some even more subtle interface to the TTFT. So it is a great obstacle for us to try to recover something from the victim prompt. On the secondly, when the length of the victim prompt is different, even the attacker uses the same prompt with the same shared prefix, the TTFT attacker gets will have some differences. Some cases, like if we want to recover a very long system prompt, this will harm our efficiency. Just like that kind of performance will be harmed. Taking this as an example, the first sentence is you can have and for appending 10 tokens, and you can have appending with 512 tokens. The attacker use the same one to try to get close to the prompt, but the TTFT he get might be different according to the victim prompt's length. So to try to resolve these questions, we come up several possible ideas. To tackle the first problem, we try to guess n tokens by n tokens. The prediction we mentioned before is a token by token, but how about using 2 tokens by 2 tokens or n tokens by n tokens? Also, we may need more time to guess because the searching space is scaled, but we can have fewer trails because the AUC is increased. So to first study this kind of phenomenon, we write a simulator here, and it is not shown and in the issue. And for the second question about the length according to the latency, first maybe we can guess the length range of the victim prompt, and then select the corresponding classifier. The length range of the victim prompt can be deduced from the TTFT that attacker can get. With the new attacks comes the corresponding possible mitigations. We provide several possible mitigations methods here to mitigate our attacks. The first one we want to mention is try to detect some harmful behavior on the server side of the echelon. For example, if we consistently found someone asking the same question and always asking for flash cache in a very short period, this might be a very harmful behavior. And another behavior can be taken into consideration is someone is always sending in the JSON that he sets the parameter max net new tokens equal to 1 to get a TTFT value. The second thing we wanted to mention is try to isolate token KV pool for different users. It's very easy to understand, in fact. The third method is try to increase the granularity of the minimum shared tokens. if the shared tokens, so if the granularity of the minimum shared tokens is increased to a certain amount, the search space of the attacker scales will scales exponentially. It could cause the attacker forever to recover tokens. And here is our PPT. We want to sum up this one. Simply shows that leakage actually exists. In fact, this is a joint work by UCAS, USTC, and IUB. We'd like to thank all of you for your persistent efforts to prompt the development of LLM, and thank you for your all. If you have more questions and have some interest, please refer to the GitHub issue. The issue is the number of issue is given in this link. Thank you.
Yes, thanks for the great talk. I think it's a very interesting topic. So maybe because maybe this talk is too short. So let me try to understand this better. So so basically you are trying to is the task like that you are trying to see, if a prompt is already asked, or you try to steal like any possible prompt? Like what are the attacker trying to do?
In fact, we assume a fine-tuned language model is already obtained by the attacker, and this model is trained by some targeted data set. In fact, attacker can get a range of some valuable things, simply like a data set of system prompt, and this model is assumed already acquired by the attacker. Yeah.
I see.
So it sounds like the attack use this attacking technique can try to review others' prompt. Is that
right? In fact, it is nothing. It is more like something to simply assure this is right, but not simply searching. The given knowledge is I mean the fine-tuned language model is trained by the data set, and the data set and the victim might choose one of the sentence of the data set. It might not sound like something like reviewing, but simply like something to locate which one it is. Yeah.
So, I mean, it's kind of thing. We have this intuition. There's some security to study before we discuss internally. But do you have a complete attack cases like side channel? You can observe what is historic query the system has been experienced. Now you for sure based on that. You measure the response time. So what is afterwards? Aftershock, what you can do with it? So basically, that's my question.
In fact, it is still a very initial project that is still ongoing. In the future, we might first focusing on the flash catch. In some system security field, we got some methods like evict and reload and this kind of methods. We want simply try to replace the flash cache we use by simply flooding a lot of prompts in a batch. Maybe some future work can be done, and I don't know. But this is still an ongoing work. Thank you.
Yeah. But at system level, right? Some security has a lot of related system level design. Like we can do rate limiting per user, right? This per user can be defined per IP coming or per whatever. You have to do any production. You have to do rate limiting. If you don't, it doesn't work.
Yeah. In fact, our assumption here and hypothesis here we use here might sound something like not so reasonable, because it entitles the attack great privileges. Yeah.
Yeah, I was thinking if you can disclose some other user's request or decoding, then it's serious. Okay, that's cool.
Yeah. Thank you.
Yeah, do you have your GitHub's address?
Can you share the slides on our Slack channel?
Yeah, do you mind if we
Wait.
share your slides on our learning materials? Yeah.
Oh, I can share the slides here.
Okay. Yeah, we can collect all our materials and share the video records and the slides on our SGLearn learning materials. Yeah.
Thank you for your interest in our work.
Okay. I think it's pretty interesting.
I still want to know more. Yeah, I have the same question as Hai. So what can you do with this side channel attack right now? For example, can you see what's existing in the KV cache? Like, can you see what other users are asking? Is this the attack?
Maybe what I want to what our group want to spotlight on might be something like since the LLM is developing so quickly, we use we use various ways to try to amplify the performance of the different service system of LLM. Maybe some security works can be done here, and so maybe what we want to spotlight on is something like, yeah, there is a problem. Maybe it should be paid more attention here. Someone simply ignores this just like this. Yeah, something like for a long time, there are few people care care about this kind of topic. Yeah. So basically, I don't think our work will be a very practical way because in fact we don't have some basic knowledge about artificial intelligence. Maybe so we maybe so this work and this paper is written for simply want to gain the readers for some more insights.
May
Okay.
I re-explain my understanding, and you tell me if I'm on the right track or not? I'm trying to grasp this. So what you're saying is, let's say we have a deployment and we have a user that is using, let's say, a prompt, and that we'll call that user A. And user A uses a prompt, and the server caches that prompt. You're saying that the attacker could reverse engineer, if given enough time, that prompt by trying to guess its prompt and seeing if it's a cache hit or a cache miss by iterating through the tokens and seeing the response speed of the server. Is that correct?
Yeah. In fact, I come up with something like a phenomenon. When in a very small environment that the data set is small and the user is asked to simply ask one of the question here, and the attacker will try can try to reveal which sentence he asked.
That's really interesting.
Thank you for your interest.
Yeah, and when you do the attack, you have to send a lot of requests, right? And in the meanwhile, other users are also sending the requests. So for example, in a real online serving engine, the cache is very dynamic. In this case,
Yeah.
well, is it still easy to attack, or this kind of online dynamic already resolve this vulnerability?
Yes, this will, yeah. So we use some very strong hypothesis here. Maybe what the environment and our design is something like since the user is small, the number of the user is very small, and the attacker is also a user, and he even has the ability to flash catch to use some function like flash catch. Yeah. In a very modern scenario, I don't think it will work. But since this work is a very initial one, yeah.
So the maximum exposure in an ideal system would be that the attacker could identify if the prompt that they're using is in the KV cache created by some other user.
Yeah.
Okay. This is very interesting. Thank you.
Thank you.
I appreciate the clarity.
Yeah, amazing. It's my first time hearing about KV cache attacking. Yeah, and I guess traditional security research do a lot on this, but I mean, I don't see anyone in the security academia caring about attacking on KV cache. But anyways, thanks so much. And we still have several, maybe possible 1 or 2 minutes left. Let's welcome new members to our
Yeah, James,
community.
do you want to do a quick intro at the last minute?
Oh, yeah. Hi, my name's James. I'm a current student and wanted to, I guess, contribute.
Yeah, so I know James through Twitter, and he is very into ML system, and he shows interest in SGLang. Yeah, so welcome him to the contribution.
Yeah, welcome.
Okay, and so I guess there's still someone waiting here to introduction. Am I right? Or he isn't here? Okay, so if not, yeah, we got to end our meeting, and there's something we can discuss quickly. Right now we have so many things on our roadmap. Everyone can see that, but there are 3 things maybe in the highest priority. The first thing is speculative decoding, and the second thing is multi-layer or hierarchy KV cache, just like L1 cache and L2 cache, these kinds of things. And the third thing is prefix and decoding disaggregate. So if anyone feel interested in here, maybe you would like to join this kind of discussion, feel free to go in the general. Yeah. Hello. Oh yeah. Jafan discuss himself, and let's welcome him in the chat. Yeah. Okay. So are there anything left for us to discuss today?
Yeah, I just follow like Linker's presentation is cool. The idea actually we discussed it internally before in SGLang channel with Yin and I mean we didn't do a lot of experiment, but I think Lianke, if you're interested, we can chat in the Slack offline. I would still struggle to find a concrete attack, right? After because to observe the KV cache is populated it is obvious, but how to use it for an attack, it is $1 million question. Yeah.
Thank you for your interest.
Yeah.
Okay, possibly show me 1 month of salary if you earn that much. Okay, thanks everyone for joining, and we're gonna have next meeting 2 weeks later, and maybe discussing about Archf, this kind of thing. So if there's nothing left, we can end our meeting, and thanks for joining. Yeah, welcome next time.
Yes, thank you.
Yeah,
Thank you all for
bye-bye.
putting this on. It's wonderful to chat with devs instead of just using GitHub.
Yeah.
Okay.